This video is going to have a look at an example involving two-step connections using adjacency matrices. An adjacency matrix allows us to represent the number of connections between two objects. Go and have a look at the video introducing adjacency matrices if you need more information on what they are or how we can create an adjacency matrix. So in this example, we have communication connections between Chris, Ali, Kate, and Remy, and they're shown in the diagram. The example first asks us to write a matrix Q to represent these connections. Now they want us to label the rows and the columns in alphabetical order using the first letter of each name. If there is a direct communication connection, we will use the number 1. If there is no direct communication connection, then we will use the number 0. So let's start off by completing the matrix. And to do that, I'm going to label the rows and the columns with the first letter of each name, and I'm going to put that into alphabetical order. So it's going to be C for Chris, E for Eli, K for Kate, and R for Remy. And I'm going to do that down the side as well. And then I'm going to go in and add in my diagonal row of zeros because they cannot be communicating with themselves. So having a look at Chris to see who Chris is communicating with, and I can see that Chris is communicating with Eli, with Remy, and with Kate. So he is communicating with all 3 other people. So when I go ahead and complete his row, I can put in 1s because he is communicating with all 3 of them. Next, I'm going to have a look at Eli, and I can see that Eli is communicating with Remy. He's communicating with Chris, but he is not communicating with Kate. So when I complete his row in the matrix, I put a 1 in for Chris, a 0 for Kate because there is no communication, and a 1 for Remy. Moving on to Kate, I can see that Kate is communicating with Remy. She's communicating with Chris, but she's not communicating with Eli. So when I complete her row, I will put in a 1 for Chris, a 0 for Eli, and a 1 for Remy. And then finally, looking at Remy, I can see that he's communicating with all 3 other members. So I can go ahead and complete his row with 1s. So that is my matrix. And because they've asked me to call it Q, I'll put a Q equals. And that is my answer for question A. Question B is asking what information is given by the sum of column R. So having a look at the sum of column R, and that is going to be equal to 3. Now that information is telling me how many people Remy is communicating with, and that means that Remy is communicating with 3 people. And I can confirm this by looking at the original diagram, and I can see that Remy is in fact communicating with 3 people. So moving on to question C, and question C is asking us to square matrix Q. Now I'm not going to do that calculation, I'm just going to put up the answer. If you are interested in how to do that calculation, go back and have a look at one of the videos on how to multiply matrices, specifically how to multiply them to the power of a number. So that is my answer to option C, what the matrix Q squared is going to equal. Now, when we are dealing with adjacency matrices, when we are squaring the original matrix, what we are seeing is the total number of paths between the 2 objects if we are going through another object. So not going directly, but going via one other object, or in this case, one other person. So for example, if I'm looking at Chris and Kate, I can see there's only one pathway for them to communicate via another person, and that is going to be to go via Remy. So to communicate from Chris to Kate and going via a 3rd person, the only pathway is for Chris to go to Remy and then down to Kate. The pathway between Chris and Kate direct is not counted because it is not going through another object. So looking at question D, we want to use the matrix Q squared to find the total number of ways that Eli can communicate with a person via another person. So to do that, we're going to look at Eli's row and we're going to total it up. So 1 plus 2 plus 2 plus 1 is going to equal to 6. So there is a total of 6 ways that Eli can communicate with another person if he goes via a 3rd party. And question E is going to ask us to write the connection change for those 6 ways that Eli can contact another person using a indirect route. So the first one is going to be for Eli to contact Chris. And for Eli to contact Chris, he can go through Remy, who can then in turn contact Chris. So Eli to Remy to Chris is going to be the first option. There is no other pathways for Eli to contact Chris via one other person. So moving on and having a look at Eli himself. Now, I know it's a little bit odd for Eli to want to contact himself by another person, but it is an option and the question doesn't specifically exclude it, so we will list it down. So for Eli to contact himself, he can go through Chris. So Eli to Chris and then back to Eli, or he can go through Remy. So Eli to Remy and then back to Eli, but Eli cannot contact himself through Kate. So moving on, we'll now have a look at how Eli can contact Kate. And for Eli to contact Kate, he either goes through Chris or he goes through Remy. So Eli to Remy to Kate, or Eli to Chris to Kate. And it leaves for ways for Eli to be able to contact Remy. And for that to be done by a third person, it has to be done through Chris. So Eli to Chris back to Remy. So that are the 6 ways that Eli can be in contact with other people using a intermediary or using a non-direct route. So that is an example of how we can use adjacency matrices to be able to work out connections between people, either directly or through another person.